Okay, so let's take what we have written down and put this into a nice neat format to write our final vector for the electric field at point A. So let's move over here. We see that the electric field vector at point A is the sum of the electric fields in the x component, I hat, plus sum of the electric fields in the y direction, j hat, is all going to equal to, so we see in one part for the x component we have 2k over a squared square root of 5 multiplied by q1 minus q2 I hat plus k over a squared square root of 5 times q1 plus q2 j hat. And now we'll recognize that k, a squared, and the square root of 5, that is in common in both of these terms. So we can go ahead and take all of this out. And we can write this vector as k over a squared times the square root of 5 multiplied by 2 times q1 minus q2 I hat plus q1 plus q2 j hat. And that's how we can express this aptly. Now let's work with this expression here in more details. So let's work with this more details. So just gonna move this bit down. And gonna try to move this over to our picture. Hate it when it does this. Oops. Really starting to hate that. Okay, so now let's take a look at our picture over here. And if we look at this carefully, we see that if the charges were of the same value in magnitude, meaning that q1 was equal to q2, so let's say q1 is equal to q2, which is equal to q, then we can automatically see that under that premise, that this electric field vector only has a y component, because the difference of q1 minus q2 would yield 0, and 0 times anything is just 0, so the I hat component is 0. So we see this is just equal to the sum of the electric field vectors in the y direction, j hat. So if you had known that the charges were the same, then you could abuse some symmetry here and not do all of the accessory math and just worry about the y components. This is a good strategy. Now let us change this up a bit and let us say, how would our result change under different premises? So, one premise is, suppose that q1 and q2 are equal but oppositely charged particles. How would this change our result? Likewise, suppose that the charges were unlike and unequal in charge. So, how would that change the result? So that's a second exercise I encourage you guys to explore on your own. So, by having this set up here, we don't necessarily have to use all this information or plug in the numbers if we can see that there is some symmetry here, as was deliberately orchestrated with the positions of our particles and our point of interest. So, those are things I leave you to answer. I encourage you guys to do. Now, in the next video, we'll deal with a different position in space and talk about point B, if you recollect that part of this problem.